Okay, this is a question on projectile motion. You can tell that from the parabola shape that you can see in front of us. However, it's worth reading the question very, very carefully. We are told that air resistance acts on the projectile. Now, when air resistance acts on the projectile, you should be aware that the motion will not be parabolic. It won't be this nice symmetrical curve. And that's really what the question's getting at here. So we've got the acceleration of the projectile at some point, which is A, and that's going to have vertical and horizontal components. Now, in the perfect case where we have zero air resistance, then the horizontal component is always zero. And that means we can have a constant speed in the x direction. Now here we have some air resistance, which means that the horizontal component of the acceleration is not going to be zero. In other words, we're going to experience some slowing down in the x direction, and so therefore we must have a non-zero acceleration. So the question there is about the vertical component. Now, to think about this, if we're at position P, we're going to have two forces acting on the object. Now, the first of those is the weight, and that will produce on its own an acceleration of 9.8. Now, with the air resistance is either going to be up or down, because we're thinking about the vertical component here. And in this case, it's going to be going down. Why? Because my point P is on the left-hand side of that peak point, we are moving upwards. Now, air resistance will oppose our motion, and so therefore it will be pushing down. Now, the question here is, what does that mean about the acceleration? Well, looking from a forces point of view, we've now got a greater force acting on the object, greater than the weight of the object. And so therefore, we're going to have an acceleration which is greater than what would be produced by weight alone. And hence, we're going to have the answer B here.